right, you guys can see my screen, right? I still can't figure out an easy way to access the chat while I'm looking at.
Yes, we can see it.
Okay. All right, so Lab Quiz 3 is going to cover a variety of descriptive analyses that you can do in SPSS. So the basic descriptives that I've covered are going to include visualizations, so graphs and charts, mean and standard deviation, and z-scores. So we're going to be touching on a little bit of everything. So as usual, you need the instructions worksheet, and you need to use that to create your answers document. And you're going to need to have my SPSS data set that I've created for you open. This here is the variable view. This here is the data view. There's a few different variables here. Participant ID just keeps the participants in the proper order. I have the categorical variable of gender, which, as you can see, I've coded the categorical values for. One indicates that the participant indicated a female. 2 indicated they were a male. 3 would be unspecified. Likewise, major is a categorical variable, and there are labels associated with it that need to be created in SPSS such that the numerical codings associated with the categories mean something. Then for the variables of exam 1 and GPA, those are going to be quantitative, so no labeling necessary. And then this is the data itself. So the instructions for this lab quiz are the same as the last one. You're going to want to write your answers in one document and keep your output open as you're doing your analyses, and then save them when you're done. So the prompt reads, the data provided depicts some basic hypothetical information about a sample of 20 undergraduates. The variables include participant, gender, college major, score in an exam, and GPA. Use SPSS to provide the following answers. So first up, we're going to go analyze descriptive statistics. We're going to run some frequencies. So in the frequencies drop-down menu, create frequency tables for gender and major. This is an example of a question where, in addition to having the graph, the frequency distribution in your output, I would recommend actually including those numerical values in your answer. So since I'm asking for what are the frequencies for gender and major, I like to make sure that not only are you able to run the analysis, you're able to pull out the appropriate information. So analyze descriptives, frequencies. Put the variables that you want to have frequency distributions for over here. Display frequency table, and you can run OK. Right? So I can run as many of these frequency table generations on as many variables as I want at once. I don't have to do a separate one for gender and a separate one for major. You can see that it spits out both, and it's got the labels for everything. If I had not created those categorical value labels for these variables, this would be reading 1, 2, 3, and I wouldn't know which group was which. So that's why it's important to have those categorical labels available. So can anyone tell me, in this frequency distribution for gender, how many women are there? I'm going to assume someone said 9, somewhere in the chat, maybe. Right? The idea is that SPSS gives you a fair amount of information to look at. The idea is knowing where the key stuff is. This column right here are the actual frequencies for your groups. So there's 9 women, 9 men, and 2 who indicated unspecified. Then you have other information present, the percentage of the various groups, cumulative percentage. As I covered in the visuals part of the descriptive stats lecture, it's all about just giving different options for visualizing, describing, or summarizing your data. So likewise, to answer the question about major, take that same information and write up what the frequencies are for your various categories. So when you're doing a frequency table in SPSS, the key frequency information is listed right there in that frequency column. Okay. If you at any point have any questions, I'd appreciate it if you would just turn on your microphone, because again, it's like a pain in the ass to navigate from screen share to the chat. So if you do have any questions, please just turn your microphone on and feel free to ask at any point. All right, so this is more of a conceptual question. You don't need to run a separate analysis here, you just need to write your answer. So why would a mean and standard deviation for gender and major variables not be particularly informative? Think about why a mean and standard deviation for a categorical variable doesn't make sense. You can do it. You can put gender into a mean and standard deviation analysis, and SPSS will spit values out at you. Critically, though, you have to recognize that those numbers are without meaning. You cannot interpret them. Think about why that is. Think about why, even though SPSS will let you run a mean and standard deviation on that variable, why do you not need to bother? Why is it that a frequency alone is a meaningful way to communicate about those categorical variables? Okay. So moving on to the quantitative variables, the exam one and the GPA. So here we're going to go analyze descriptive statistics descriptives, and we're going to get the mean and standard deviation. Additionally, we're going to save the variables as a standardized values. I just posted the lecture for z-scores today, and I still need to record that lecture, but I want to show you how z-scores can come into play in your descriptives analysis in SPSS. So back to my data. So then put my quant variables in there. Like I said, select this save standardized values as variables. This is going to generate z-scores for me. So make sure to have that selected. Shouldn't need to do anything else. And this is what I get. So again, you're going to want to pull the information out of this output to indicate that you know what you're looking at. So in that question, it says, what is the mean and standard deviation for exam one? The idea is you just need to be able to identify that that specific information is available right here. So the mean for exam one is 81 and the standard deviation is 9.48. Again, the skill that goes beyond just churning things out of SPSS is making sure that you know where to find the information that you actually need. So min and max, that's perfectly valid information to have, but more important typically for your write-up is going to be mean and standard deviation. So practice looking at this output and knowing that there's only specific things that you need to pay attention to. All right, so one thing if you go back to the data set that you'll notice is that both in variable view and in data view, you'll notice that there's this new variable called z-exam and z-GPA. This is because I requested SPSS to save those variables as standardized scores. What that means is that not only has it generated a variable for the z-scores for both variables for all participants, it actually populated that actual information. So it created the z-score standardized variable, and it actually calculated my z-scores for me. So these are just the standardized versions of these exact same variables. That's what it means to save as a standardized variable. It just generates those z-scores for you. Okay, so then we're actually going to do something to those z-scores. Again, I haven't recorded my z-score lecture yet, but if you got a chance to look at the slides, you'll notice that I allude to something called the standard normal distribution. This is the idea that sometimes it's worthwhile to standardize your variables that are on different quantitative scales, right? GPA and exam are on very different quantitative scales. The exam variable was on a range from 0 to 100. GPA ranges from 0 to 4. If you want to be able to compare between those two variables very easily, you can standardize them, which z-scores accomplishes. Z-scores are basically always, not basically, they are always on a scale of -4 to +4. So it puts these two very different numerical scales onto a shared similar standardized scale. So one facet of the standard normal distribution is that if you were to go back and use those newly generated z-scores, go back to the descriptives function, find the mean and standard deviation, what do you notice? Right, here's how you do that. You don't need to keep this selected. You can. It'll just copy and paste the same information over again. All right. So whereas the mean and standard deviation for the unstandardized exam and GPA variables, what do we see is true about the descriptives for your Z-scores for exam 1 and GPA? Okay. What you're going to want to do once you've visited the lecture materials for Z-scores and the normal distribution is apply the way I defined the standard normal distribution to what you see here. So this mean and standard deviation for your standardized versions of the variables are quite different from what you see up here. And you're going to want to think about what this means. Why is the mean 0 and the standard deviation 1 for both of your newly standardized scores? This gets at the heart of what this term standardization means. Okay, questions so far? All right, so let's move on to question 5. So using the graphs chart builder function, create a pie chart for major. Based on this pie chart, how would you describe the breakdown of majors for this sample? Do you think this is a good way to visualize the major variable? Why or why not? So for this question, you're going to create the chart. You don't need to screenshot the chart into your answers. You certainly can if you want to, but mostly this question is about thinking through the various rules of thumb about why certain visual choices are ideal for certain kinds of data. So let's make a pie chart. Hell yeah. To create your chart, you're going to go to Graphs, Chart Builder. I'm going to say I don't want to see that anymore. If you ever see this dialog screen, just click OK. You don't need to do anything here. All right, so to create a chart, you need to select which one you want. Pie chart. You're going to click and drag that choice up here into the gallery. And then you're going to drag the variable in question down here. This is just a preview. That's not actually what your chart looks like. You need to hit OK to actually see the finalized chart. Okay. So here's your chart depicting the breakdown of major. The basic idea is to look at the pie chart and ask yourself, what's the story that this pie chart tells? Right? Clearly, there's a lot of psych majors. As easy as that. Then ask yourself, based on some of the general guidelines for graphic choices, why do you think pie chart might be ideal for the depiction of the data for the major variable? All right, so using the chart builder, create a histogram depicting exam scores. How would you describe the spread of exam scores? So just describe the variability. Do you think this is a good way to visualize the exam scores? Why or why not? Let's go make a histogram. Can reset to get rid of that pie chart. Histogram. Click, drag, exam 1, drag. All right, so here's my histogram. Again, think about whether or not this is an effective tool for communicating information about exam scores. Recall that a histogram is a bar chart that depicts frequencies. It's a subtype of a bar chart. So again, ask yourself whether or not histogram is an appropriate choice for the depiction of the data for exam 1. Then lastly, again using Chart Builder, create a line chart for the GPA variable. Do you think this is a good way to visualize the GPA variable? Why or why not? So then one last time, back in our Chart Builder, reset, line, and that was for GPA, right? And here we have our line chart depicting GPA. Again, the exercise here is to think about, is this the ideal choice to depict GPA? Do you think it's effective at communicating about the data? Do you think it looks nice? These are all the various criteria you can use. At a certain level, any graph can be used to depict data accurately, And the question is asking yourself whether or not it goes beyond merely depicting the data accurately. Do you think it looks like a good choice? Do you like the way it looks? And do you think it communicates about the data as clearly as possible? Again, the rules for determining which graphic you're going to use are not hard and fast rules. They're rules of thumb, they're guidelines. The idea is that the guidelines are there to help guide you in the direction of which chart might end up looking the best and communicate most effectively. This chart, whether or not you like it, is not right or wrong. It's depicting the data accurately. The question is, do you think it does the best? And at a certain level, you can make that evaluation on your own. Okay, so that's it for walking you through the steps for the lab quiz. Again, you're going to want to fill in your answers to both numerical questions and conceptual questions and turn that in the lab quiz 3 answers submission. For your output, again, you don't need to do anything to this beyond just saving it. So you just save your output. You don't need to transform it into a PDF. You can if you want. You can just save it as a .spv. That's perfectly fine. I would just make sure you save it somewhere where you'll be able to find it. So desktop or on your USB, in your files for this class, whatever works. Okay, so that'll do it for walking you through the lab quiz. I'm going to, at this point, just hang out for as long as anyone else is in the Zoom chat and answer any questions, give you a chance to work on it. But beyond that, that's basically all you need to know to properly do lab quiz 3. So with that, I'm going to end the recording and just take any questions.